In this week's episode of Recreate a Blog, we are going to understand closures in JavaScript. Of course, this blog was written by the one and only Afinia de Charlotte. Hope I got your name right. Please forgive me in case I mispronounced it. Of course, link to the blog in the video description down below. Let's get to it. JavaScript closure is one of those topics that can be hard to wrap your head around simply because of how it's often explained. Most tutorials just tell you that it's a function within a function, but in reality there's a deeper meaning behind it all. As stated by Douglas Crockford, the father of JSON, writing an ECMAScript language without understanding closure is like writing Java without understanding classes. Let's start playing with some code. I've gone ahead and created the directory understanding closures and opened it in Visual Studio Code. So the first thing I want to do, let's create a file and call it closures.js, and let's log hello world. Okay, next thing we want to do, we want to create an index.html. Let's quickly spin up a HTML boilerplate, and we'll have an h1, and let's just say closures. Okay, next thing we want to do, we want to add a script tag, and over here we want to add our closures.js as a source. Okay, wonderful. So let's open this in live server. Wonderful. As you can see, we have closures over there. Let's open our developer tools. Let's move to our console and we can see hello world. Wonderful. Let's go ahead and clean everything in our closures.js file. Let's go ahead and declare a variable x and assign it to the value 0. Let's create a function add number and simply return 3 plus x. Now let's go ahead and console dir add number. Okay. This code in theory is a closure. However, it's not very efficient. It uses a global scope and there's nothing to protect it against change. A lot of people often forget that JavaScript is a lexical scoping language. This means inheritance flows inwards. A variable outside a function is available for usage within a function, but not the other way around. You can't use a value that's been declared inside a function outside it. Let's go ahead and comment everything out. Let's create a function, closed function. It takes in x as the parameter and return a function add number. Now let's go ahead and create this function add number. Now this function simply returns x plus 3. For example. Now let's go ahead and console dir close function, and let's go ahead and pass 3 as the argument. Switching over to our browser, we can now see that it is a closure. So essentially, when we wrap our code inside a function, we are enclosing the scope and making the variable passed into the function independent. So far, it's clear that closure is a consumption of a variable outside the function. I've gone ahead and created a new file, closure2.js, and the code is almost identical to the one in closure.js. So the question is, if closure is the consumption of a variable outside a function, why is the code in closure2.js not a closure? Well, the reason is because of how JavaScript evaluates the statement. The scope of the function is created once and memory gets allocated for it. Processing happens until it reaches the end of the function and the memory gets released. There is no permanence gained in the exercise, and whatever value is created is forever lost. Well, that's a lot to take in. Let's try to understand it even better by creating a standard counter function. I am going to close this file. Let's go ahead and comment out everything in our closures2.js. Let's create a function, open function. Let's create a variable counter and assign it to a value 0. Let's increment counter, and finally and log counter. Let's call our function. Let's call it one more time. Let's go ahead and break it down. When the function gets called, memory gets allocated. Processing happens. It does whatever it needs to do to execute the code. At the end of the function, memory gets released. Now this process gets repeated each time the open function gets called. Keep in mind that this code is not a closure because variable scope is not external to the function. Let's make some changes to our code. Let's change the function title from open function to enclosed function, just for readability purposes. Let's create a variable increment and assign it to a function. Now let's move these two lines of code into the increment function. Let's return the increment function. Finally, let's create a variable countMe and call the enclosed function. Last but not least, let's play with increment. Let's do this one more time. We have essentially wrapped a previous function within a function, and this creates another scope, a sort of a ring fence around your code that tells JavaScript not to destroy your function when it ends. The counter variable in the code becomes the enclosed variable because it's outside the function being called, that is increment. As a result, you can create an unlimited number of function instances with its own set of unique values. This part of the code is the scope, and running memory of this function is enclosed within the wrapping function. This particular bit of the code instantiates the instance of the function. Each instance created tells JavaScript to keep track of and isolate the memory. When countMe and the method increment is called, it keeps track of the local variables for that particular instance. The variable counter is therefore the closure in our code. In a way, closures are just functions with preserved data. When you create a closure, you're telling JavaScript to remember the state of the things inside your function, and only the variables that are used are considered closures. This is particularly useful because closures are stateful functions in that they remember their private variable data after a call. The variables are private because external functions cannot access them with an explicit call for access. This allows for the entire function to be self-contained, and its variables are protected against unwanted change. Closures in JavaScript are therefore a way to succinctly section off code into a modular and self-contained manner without the need to explicitly create a class. The usage of closures allows for replicability in code and reduces the amount of global scopes needed. Writing closures is more than just the act of putting a function inside another function. It is a technique used to create variables that are protected against external change, truly isolated from the rest of the application, and are persistently stateful. That's it for this episode of Recreate a Blog. I will definitely do a follow-up on closures. Main man himself, DC_Dalin. Peace out.